Chapter 3, Defining and Measuring Variables. This chapter is about measurement and how you can have a valid and a reliable measurement. First, let's learn some definitions. A variable is a characteristic or condition that changes or has a different value for different individuals, like age. Different people have different age, or gender, or your score in a test, or the time that takes to do something. In research, we need variables, or we use variables because we want to compare the effectiveness of different methods or different situations. So we have to measure the variables to see how the variables change under different conditions. For example, how depression scores change as response to therapy. There is an important distinction between a variable and a construct. Usually variables are very easy to define, easy to observe, and easy to measure, like age, time, gender, score. Constructs are kind of variable that is hard to define, it's hard to measure, like intelligence, motivation, self-esteem, parental involvement. This kind of constructs that are hard to evaluate. If you're dealing with a construct in a research, you have to use an operational definition, which means a definition that is specific to your research. It's not like a general consensus on what exactly this variable is, so you define it somehow that it's only applies to your research. For example, you define students' motivation as the number of hours they study. Two main features of measurements are validity and reliability. Any kind of measurement that you do, you have to be concerned about the validity and reliability of your measurement. Why should we be worried about validity and reliability? Because everybody may have a different idea of how to measure a specific thing. For example, if you look at this picture, it asks the users to predict, if you rotate the object on the left side, which of the objects in the right side you're gonna get. So they have to imagine, if you rotate this object, how it's gonna look like. And this is actually claimed to be an intelligence test. We may agree or we may disagree that this is actually an index of intelligence. Or another example is this one, that they have to put things together like a puzzle to make the shape at the top. Or somebody may say a test like this is going to be an IQ test, like, they have to do some mathematical computations, and that's considered an IQ test. So to establish validity, you must show that measurement procedure is actually measuring what it claims to be measuring. So if you have made an IQ test, you have to show that it really measures IQ, not something else. And in your textbook, different types of validity are listed, like face validity, criterion-based validity, construct validity, that I'm going to explain here. The first one is face validity. Face validity is the simplest and least scientific definition of validity. It's not actually even a a good measure of validity because it just tells you if the test looks valid. Concurrent validity. Concurrent validity is frequently used in research. So you have created a test and you want to see if it has a concurrent validity. All you need to do is to see if your test scores are correlated with similar and better established measures or tests. For example, you can measure the correlation between your test and a standard test and see if students who get good scores in your test, they also get a good score in standard test. Then you can say my test has concurrent validity. Predictive validity is similar to concurrent validity except that you measure the validity of your test with a criterion that's going to happen in the future. For example, a medical science test that predicts passing the medical board exam. So if students who get a high score in your medical science test, they also get a very good score in medical board exam, that means your test has a high validity. The other one is the construct validity. Construct validity is probably the hardest way to measure the validity, but it's also the most appropriate or the most powerful way to do construct to measure validity. And because it's hard, a lot of people don't do it, because if you want to do a construct validity for a test, for example, you have made a test to measure students' aggressive behavior or to measure their aggression, and you want to see if this test has validity, a construct validity. You need to study all research on aggression. So all the symptoms of aggression, everything we know about aggression, all measures of aggression should match or should correlate with your test. And like I said, we have two types of construct validity. We have convergent and divergent. It means that in order to establish a construct validity, you have to show your test is correlated with similar tests. For example, if you have made a self-esteem test, you got to show that your test is correlated with similar tests such as self-worth, self-confidence, social skills, self-appraisal, etc. Also, you have to show that your test is not related or correlated with unrelated constructs or unrelated tests. For example, your self-esteem test is not supposed to be correlated with the IQ or a math test. That's what is called convergent validity.